in this question, we're trying to determine whether something is going to be acidic or basic if we put it into water. So if I put any of these three chemicals into water, if I have hydrogen phosphate, so this is going to break into potassium ions and hydrogen phosphate ions. Two negative. And this is potentially either an acid or a base, right? Because it could donate this hydrogen or it could accept a hydrogen. It's got a negative charge, so it can accept the hydrogen ions. And this hydrogen is available because phosphate can become a 3 negative charge. So I don't know, is this going to be an acid or a base? Well, in order to determine that, if the Ka is greater than the Kb, then it's an acid. If the Ka is less than Kb, then it's a base. But I need to know what the Ka is for this and the Kb. So hydrogen phosphate is down in our data booklet here as a base, and it's listed down here as an acid. So its Ka is going to be equal to 4.8 times 10 to the negative 13. So that's reading off of my data booklet that's here in the acid column. This is its Ka. But its Kb can be determined using this for this molecule, or this anion. So I have to use the Ka of its conjugate acid, and I take Kw divided by this number, gives me the Kb. So Kb equals Kw divided by the Ka of the conjugate acid, and so it's going to be 1.0 times 10 to the negative 14 is Ka, or Kw, and the Ka of hydrogen phosphate, or dihydrogen phosphate, is 6.2 times 10 to the negative 8. And so if I take those two numbers, second one, divided by 6.2, 10 to the negative 8, gives me 1.6 times 10 to the negative 7. So since this number is larger than this number, and it's the Kb, this is a base particle. So the hydrogen phosphate, 2 negative, plus water is going to be basic, and it's going to produce a hydroxide ion and a phosphate ion. And that this is the resulting Bronsted-Lowry acid reaction that would explain when I dissolve the potassium hydrogen phosphate into water. I can do the same thing for these two substances if I know their the Ka of this. So this would be the Ka of hydrogen phosphate, which is listed here. And then I'd need to have the Kb of the dihydrogen phosphate, and that is going to be using this Ka here, because this is when it's functioning as a base. Okay, so this is our basic principle, and then we can apply it to the reaction.